Hi, after watching the video on elements, compounds, and mixtures, in this homework video, you're going to classify the matter. So go ahead and have a piece of paper ready, and as we go through, like for number 1, you're going to write down, is it an element, is it a compound, or is it a mixture? All right, so number 1 is NaCl, or sodium chloride. And if you want, then you can study this later. You could write down sodium chloride and decide if it's an element, if it's a compound, or if it is a mixture. So that is going to be our choices. In this is called a space-filling model. That's what this picture is. And the green circles here would represent the chloride ion, and the purple would be the sodium ion. So it's sodium chloride. Is it an element? Is it a compound or a mixture? The next is sulfuric acid, and its formula is H2SO4. It's commonly known as battery acid. We'll use it a little bit in the lab this year. So we have its chemical formula, and then what we have here, this is like a ball and stick model, and we're going to be building models like this in class when we get to the Lewis structure unit, and that's what this is here. This is how the H's and the O's and the S are all connected. And again, here's our space-filling model up here of sulfuric acid. So is sulfuric acid an element? Is it a compound, or is it a mixture? Looks like Bart got in trouble with sulfuric acid. It is not a toy. All right, gasoline, it's highly flammable, and so the red diamond that you see here indicates that it's flammable. And gasoline has a lot of different things together that are not chemically combined, and most of them are some type of hydrocarbon. And as the name implies, it just has hydrogens and carbons in the formula, but there's a bunch of different hydrocarbons in gasoline, and one hydrocarbon is not chemically combined to the other. So is gasoline a compound, an element, or a mixture? Dry ice, it's that cool stuff that when it kind of makes smoke at Halloween and it's really cold, you can't touch it with your bare hands for any length of time. And dry ice is carbon dioxide. And in this course, we're going to explain why it does that. Why does it never seem to melt? And that's why it gets its name dry ice. The black here would represent the carbon atom, and the 2 oxygens would be the red here. So is dry ice, or carbon dioxide that's a solid, is that an element, compound, or mixture? Number 5, good old caffeine. C8, so it has 8 carbons, 10 hydrogens, 4 nitrogens, and 2 oxygens. Notice that the subscript after the element symbol is how many of that element there are. So 8 carbons and 10 hydrogens, 4 nitrogens, and 2 oxygens. And then here's how they're all connected in this in caffeine. And even though you don't see any carbons down here, there are 8 of them. And where lines come together, it's understood that that is a carbon atom. And so at the end of this line, it's understood that there's a carbon there, and at the end of this line, and at the end of this line. So let's see if I filled in 8. 1, 2, 3, 4, 5, 6, 7. Uh-oh, it looks like I'm missing one. Oh, there we go. Right there. 8. Okay, so that's where the carbons are. We also don't see the hydrogens here. There should be 10 of them. Well, it's understood that carbon is always going to have 4 things connected to it. And so we would put in the 3 hydrogens here. And then here we've got 1, 2, 3. It only needs 1 more. There's 1, 2. That carbon and that carbon is satisfied with 4 lines connecting it. Looks like this carbon needs 3 hydrogens. This carbon looks satisfied. Looks like this one needs 3 hydrogens. Now, what's important in this video is just for you to be able to classify it as an element, a compound, or a mixture. And for you kids in honors, knowing that carbons are understood to be where these lines come together, that's important. Knowing that carbon should always have 4 lines or 4 chemical bonds to it, that's important. And so there are just things that are understood in these structures. So let's see, I think I have now added in the 10 hydrogens. Okay, so is caffeine an element, a compound, or is it a mixture? All right, diamond. Believe it or not, diamond is carbon. And here is the structure of diamond. So every single one of these little round balls is a carbon atom. Diamond is the hardest thing that is naturally occurring on Earth, and each carbon atom is surrounded by a tetrahedral arrangement of other carbon atoms. And when we say tetrahedral, we mean that it kind of has a shape like this. And so it's just carbons in this structure, and it's huge. So diamond is nothing more than carbon, and it's arranged as shown in this figure. Is that an element, a compound, or a mixture? All right, silver. And its symbol on the periodic table is capital A, lower g. And you're probably thinking, well, why isn't it Si or something? And Si is for silicon. But silver's symbol, Ag, came from its Latin name, argentum. So anyway, so a lot of these symbols come from the Latin roots. Lead is another one where the symbol's just kind of weird. It's an element, but its symbol is, oh, I just told you the answer. Oh, well. Its symbol is Pb, and that comes from the Latin word plumbum. And it used to be in pipes, and even the Romans had lead pipes. Previously, it was used in paints to kind of give it the nice shine. It used to be used in gasoline. It was this miracle. It stopped knocking in engines. But all of that stuff is poisonous to us because lead is poisonous. And today, it's used to protect you when you're getting x-rays done. So if you've ever had dental x-rays, they put that heavy apron on you. And what's inside of it is lead. And that lead will stop the x-rays. All right, number 9, tears. This is a little more complex than I thought it would be when I was looking up the composition of tears. There's salt water, there are vitamins in tears, there are minerals in tears, and there's even natural antibiotics so that bacteria doesn't grow in your eyes. So, are tears elements, compounds, or mixtures? Number 10, steel. Well, steel has iron, and just because we're learning our symbols right now, it's capital F, lowercase e. That's a symbol for iron. It comes from the Latin roots of ferrous and ferric, 2 different charges on the iron cation. But anyway, steel is iron. It has carbon. It can have other metals in it. And it is what we call an alloy. And an alloy is a mixture in which at least one part of it is a metal. So, is steel, which is an alloy, is it a compound, is it an element, or is it a mixture? The iron and the carbon are not chemically combined. This is the space filling model, or the ball and stick model for alcohol. This would be the kind that you can consume, or you might find in, say, wine or beer. And its formula is C2, and again, the carbons are in black. And notice, each carbon has 4 things around it, 5 hydrogens represented in the white, and the 1 oxygen. So is alcohol, is that a compound, element, or mixture? Our next one is gold. Its symbol on the periodic table is Au, another symbol that doesn't seem to match the English name, but that's because the Latin name for gold is aurum. All right, air. Here's the chemical composition for air. Nitrogen air is 78% nitrogen. A lot of people think there's more oxygen in air than anything else, but it's actually nitrogen. 20% or 21% is oxygen, and then all these other gases are found in air. So is air, is it a compound, is it an element, or is it a mixture? And these are not chemically combined. Wow, look at that. That's cholesterol. C27H46O. You're probably saying, where are the 27 carbons? Well, remember that where these lines come together, that's where it's understood to have a carbon. Where are the 46 hydrogens? Well, every carbon, they don't even they don't even write out even the hydrogens that are, it's understood that carbon should have 4 things connected to it. And right now, like this carbon only has 1, 2, so there would be 2 hydrogens hanging off here. But anyway, we're not going to go through all this. This is a pretty complex structure, cholesterol. This is what if it can clog arteries. And the formula is C27H46O. So is it a compound, an element, or a mixture? All right, if you've got too much cholesterol, then this is a cholesterol fighting drug. I think this one is marketed as called Lipitor. So chemistry is everywhere in medicines, and there's great job opportunities in pharmaceuticals if you decide to become a chemistry major when you go to college. But anyway, this is the structure. If you have too much cholesterol in your blood, you'll take a medicine like this. And is it a compound, element, or mixture? And finally, here we have a sample of uranium. The chemical symbol is U on the periodic table, and it is radioactive, and it is where we get a lot of our power from in nuclear power plants. All right, well, hopefully you got those right. We're going to go over them in class tomorrow. Bye.